Hello everyone, how are you? Hope you all are fine. So I am here with you with the continue and the part 3 video. This is the third part video for the chapter, that is chapter number 12, that is sound. So in today's video we'll learn about characteristics of sound wave, and this topic is already covered in your class 8. Okay, so let's begin this chapter, and we'll know that in characteristics of sound wave what all parameters are included. So it's nothing but very familiar parameters, that is amplitude, frequency, time period and speed of the wave. So let's begin today's video. So there are three characteristics, that is amplitude, that is nothing but number of oscillations per second. Frequency is number of oscillations per second. Amplitude is your maximum displacement from the mean position. Okay, so if I try to draw for frequency, then it is nothing but how many waves are passing per second, or number of oscillations per second is nothing but frequency. If you consider the amplitude, then amplitude is nothing but a height of the wave, or you can say that maximum displacement from the mean position, and at last we will know that at which speed a wave is traveling. Okay, so let's try to understand about frequency. So frequency is nothing but number of vibrations or oscillations that takes place in a wave पर सेकंड. कितने वाइब्रेशन और ऑसिलेशन हो रहे हैं एक सेकंड में, उसको हम फ्रीक्वेंसी बोलते हैं. जैसे कि मैं यहाँ पे दो ग्राफ बनाने की कोशिश करता हूँ, दोनों में टाइम पीरियड सेम है 1 सेकंड, यहाँ पे भी है 1 सेकंड. ओके, तो इफ यू नोट दैट द oscillations in both cases are different. Okay, if you try to note that oscillation, first of all, what is oscillation? Oscillation means there is one peak and one valley, or you can say there is one crest or one trough. That means one oscillation. So if you count oscillation in first case, this is first case and this is second case, then in first case you will find that there are 1, 2, 3, 4, 5 Hz frequency, or 5 waves has been oscillated in 1 second. Okay, now see in second case 1, 2, 3 and 4. So there are 4 oscillations per second, or you can say that the wave's frequency is 4 Hz. So now I think you all are clear. So what is the unit of frequency? It's nothing but Hertz. It's named before the scientist Rudolf Hertz, and he discovered photoelectric effect. So in the honor of the great scientist, the unit of frequency is nothing but Hertz. Okay, the symbol is F, or you can write V. It's V, but its Greek name is Nu. Okay, so I think symbol is F and we must use F in order to differentiate it with speed. Okay, now let's try to understand pitch. So pitch is nothing but a parameter that comes out from frequency. So frequency interpretation, or you can say the shrillness of the sound, is nothing but pitch, that you have learned in previous classes. See, the interpretation of frequency of emitted sound by which the brain detects it. Okay, each and every sound has its own frequency, but the interpretation of each and every frequency is different from the brain side. So that is the characteristic, that is nothing but the shrillness present in a sound. So a voice can be a sharp sound, or it can be a deep flat sound. Sharp sound means there is, the wave is like this, and if the flat sound means, see, if you note, the amplitude is more sharpened, means it's changing instantaneously, but here if you see, then the change is not as more than that of sharp sound. So this is the main difference between sharp sound and flat sound. Pitch of a sound is determined by the rate of vibration or frequency of a sound wave. So it is also determined by the frequency of a sound wave. Okay, but here in order to show the sharpness, I am showing you the amplitude. So you can see that the change in frequency of a wave is more instantaneous in first case than in the second case. So I think now pitch is clear. It is nothing but the interpretation of a particular frequency by a brain that is nothing but your pitch. So I hope you all are clear with this. Now let's try to understand what is low pitch sound and high pitch sound. So here you can see, if you take this sound, or you can say if you take this time period as 1 second. So if you calculate, the frequency is 2 Hertz, and here if you calculate, the frequency is 1, 2, 3, 4, 5, 6, 7, 8. So this is 8 Hertz frequency. So this is low pitch sound as it says low frequency, and this is high pitch sound as it has high frequency, or you can say that this is flat sound or this is sharp sound. Okay. Now higher the frequency, higher is the pitch. So pitch is directly proportional to frequency. Tight string produces higher pitch. जो टाइट स्ट्रिंग्स होती है, टाइट मतलब कि दोनों जगह से फिक्स, वो हायर फ्रीक्वेंसी जनरेट करती है, ठीक है. थिकर ऑब्जेक्ट्स प्रोड्यूसेस लोअर पिच, मतलब कि बहुत ही थिक ऑब्जेक्ट है, वो अगर वाइब्रेट होगी तो उससे जो पिच जनरेट होगा वो बहुत ही कम होगा. स्मॉलर स्ट्रिंग प्रोड्यूसेस लार्ज पिच, मतलब कि ये लेंथ की मैंने स्ट्रिंग ली, उससे भी मैं छोटी स्ट्रिंग लूँगा यहाँ पे, तो और ज़्यादा फ्रीक्वेंसी जनरेट हो सकती है. आई होप आपको एग्जाम्पल समझ में आ रहे होंगे. तो आगे बढ़ते हैं. स्टूडेंट्स, व्हाट इज एम्पलीट्यूड? एम्पलीट्यूड इज नथिंग बट द मैग्नीट्यूड ऑफ मैक्सिमम डिस्टर्बेंस इन द मीडियम. Maximum disturbance in the medium on either side of the mean position. Now what is mean position, students? If you draw a graph, then your x-axis is nothing but your mean position. Mean position of, you can say this is mean position of your density, or you can say it's mean position of your pressure. So there is an either side. Either मतलब ऊपर की तरफ भी होता है और नीचे की तरफ भी होता है. एक maximum displacement होता है वेव का in upside and downside. So that maximum displacement is nothing but your amplitude of a wave, or we can say the height of the wave from a mean position, or displacement of a wave from a mean position is nothing but amplitude represented by symbol a. जैसे फ्रीक्वेंसी को हम f से रिप्रेजेंट करते थे, एम्पलीट्यूड को a से, वेलोसिटी को हम v से रिप्रेजेंट करेंगे. सो लाउडनेस और सॉफ्टनेस ऑफ साउंड इज डिटरमाइंड बाय एम्पलीट्यूड. Okay, if there is a soft sound, then you can see the displacement is less, and if the sound is louder, then displacement is more. And the fact is, loud sound travels far distances. लाउड साउंड है स्टूडेंट्स, वो दूर दूर तक सुनाई देता है. जनरली आपने डेली लाइफ में भी यही चीज़ ऑब्जर्व की होगी कि लाउड साउंड है वो ज़्यादा दूर तक, क्योंकि उसमें डिस्टर्बेंस ज़्यादा होता है, डेंसिटी ज़्यादा होती है, ज़्यादा कंप्रेशंस और रेयरफैक्शन है, उसका इंटेंसिटी होता है, उसी कारण वो दूर तक सुनाई देता है. ओके, मीनिंग ऑफ वेवलेंथ स्टूडेंट्स. सो वेवलेंथ इज नथिंग but the distance between two consecutive crest or trough. So as you all know, this is your crest and this is your trough. So if you take any of the consecutive distance between crest and trough, then you can find the wave's length. So this is nothing but your wave's length, or you can say it as wavelength, and the Greek name is nothing but lambda. So I hope wavelength is clear to you all. It's too simple. It's nothing but a distance between two peak or two valley that must be consecutive. Now coming to time period, students. So time period is nothing but time taken by two consecutive compressions or rarefactions. Okay, two consecutive compression and rarefaction. Students, one compression and one rarefaction makes a one complete oscillation. So this compression will make one peak and rarefaction will make one valley. Okay, so consecutive means एक compression के बाद rarefaction आएगा, तो उसको complete होने में, एक compression और एक rarefaction को complete होने में कितना टाइम लगता है, उसको हम बोलते हैं time period of wave. In other words, time taken for one complete oscillation, ये रहा एक complete oscillation in a medium is called time period of a sound wave. And there is a relation between time period and frequency, that is nothing but t is equal to 1 upon f. This relation you have to remember. Here it's given t is equal to 1 upon nu. Nu is nothing but your frequency f. Okay, so hope आप सबने ये सब कुछ नोट कर लिया होगा. तो अब हम आगे बढ़ते हैं. In order to know the speed of wave or velocity of wave. So velocity of wave is nothing but the distance traveled by a wave in 1 सेकंड, 1 सेकंड में वेव ने कितना डिस्टेंस ट्रैवल किया उसको हम बोलते हैं वेलोसिटी ऑफ वेव. इफ यू रिमेंबर चैप्टर नंबर 8 स्टूडेंट्स, व्हाट वाज द वेलोसिटी ऑफ वेव्स फॉर्मूला? सो वेलोसिटी is nothing but speed upon time. Sorry, distance upon time. Yes, it's distance upon time. So if you consider a wave, students, then what is the distance covered by one wave? It's nothing but your lambda. So wavelength upon time is nothing but your t. So here the relation is v is equal to lambda by t. Okay, so I hope this relation is clear, but right now we have studied that t is nothing but 1 upon f. We already know that this t is nothing but, here t is 1 upon f. What is t? It's 1 upon f. I am writing it more clearly so you may not be confused for the same. So t is nothing but 1 upon f. So now what I can write? So see students, first formula that we have learned is speed is equal to distance upon time, that is lambda upon time. We have t is equal to 1 upon f. So if you are writing this equation, then we can write it v is equal to lambda into 1 upon t. From this equation I can write that f is nothing but 1 upon t, right? You just exchange the position from LHS to RHS, then you will get this equation. Now you see and compare this value, then you will find that v is nothing but equal to lambda into f, where I have replaced this 1 upon t with f. So v is equal to lambda into f. So that means that speed of a wave is nothing but the product of wavelength and the frequency of the wave. Speed of a wave is nothing but the product of wavelength of a wave and frequency of a wave. Okay, so here the lecture is ending. So I hope आपको ये पूरा लेक्चर अच्छे से समझ में आ गया होगा. एम्पलीट्यूड क्या है, फ्रीक्वेंसी क्या है, टाइम पीरियड क्या है. ठीक है, तो ज़रूर से लाइक कर दीजिए वीडियो को. थैंक यू फॉर वॉचिंग द वीडियो.